The transducer, this is potentiometer. See here, this is the circuit for potentiometer. You have seen in radio, TV and your car stereo set. If you want to increase the volume of your radio, so you are going to push one knob, so automatically the volume will increase. You can take your fan, okay, domestic fan. So in your room, fan is rotating, you know. So you want to adjust what you are doing. When you are going to rotate one knob, what is happening? Automatically the speed of the fan will be reduced or increased. How? The voltage flow will be restricted or will be increased. Based on that, the fan, rotation of the fan will increase or decrease. How? This is based on potentiometer. What you are using in your home to control the fan, it is a rotary potentiometer. What you are using in your radio, moving one knob, moving here and there, right side and left side. So that is called a linear potentiometer. So in potentiometer, there are two types of potentiometer. One is what? One is linear potentiometer. This is linear potentiometer and rotary potentiometer. So there are two types of potentiometers. Okay, you can control either a moving, that is sliding movement, or rotational movement. Okay, the rotary potentiometer. There are two types of potentiometers. See, what is the principle of potentiometer? It is a resistance based transducer. Resistance based transducer. Potentiometer consists of a resistance wire moved around non-conducting material with wiping contact. Wiping contact means, you see here, this is wiping contact. So when you are going to move this, it is having the flexible movement. It will cut this resistance. When you are moving, the resistance will increase or decrease. When you are going to give the voltage, this is, you assume this is VI, V in. When you are going to give 5 volt to this potentiometer, when you are going to change the resistance, automatically the output will come from 0 volt to 5 volt. Completely you are restricting means 0 volt will come. So there is no resistance means 5 volt will come. So if there is a resistance in between that 0 to maybe 4.5 volt will come or 2.5 volt will come. So based on the voltage you can control your speed of the motor or your volume of speaker, all those things you can control. How? You are varying the voltage. That's all. So the concept is you are varying the resistance, then you are varying the voltage. V is equal to IR, you know that. So V is directly proportional to resistance. When you are going to change your resistance, automatically voltage will be changed. So that's what the principle behind this potentiometer. See that. When wiping contact moves, resistance will change. According to resistance change, voltage output will change. What will be the voltage output? R2 by R1 plus R2. So based on this R1, R2 into V, if you are using this formula, you will get V0. So this is the potentiometer circuit. See the potentiometer circuit V1 we are giving. So we are changing the resistance. So based on the resistance, output will be changed. So based on this condition, the potentiometer is working. The strain gauge. Next one is strain gauge. Strain gauge is of yes, please.
V R2 by R1 plus R2 into V. V is the input.
Yes.
Input.
So you are going to find what will be the change in resistance, and then after that, so the how much if you are that resistance, if you are multiplying with the V in, then you will get how much the V output. Okay. The strain gauge. This is a transducer which is used to find load, force, pressure, all those things you can find. So when you are having some force parameter in a physical phenomena, then you can use this strain gauge to find force or pressure or load. Okay. See, the strain gauge is also a resistance based transducer like a potentiometer. The strain gauge resistance is changed when mechanical strain is released. There will be some mechanical strain. If there is a mechanical strain, automatically the strain gauge resistance will be changed. When the resistance change happen, what will happen? Normally, if you are giving some voltage, little voltage, definitely the voltage also will change. You are giving an input voltage, then resistance will be changed based on the mechanical strain. Then automatically output voltage will be changed. You are going to measure how much the change or how much the output voltage. Then after that there will be some formula to find out. So you have to find how much the resistance changed and how much the voltage is coming as output. See, the variation of output is proportional to mechanical strain. The variation, how much the variation? More mechanical strain means more variation will occur. Less mechanical strain means less variation will occur. See, the variation of the output is proportional to mechanical strain. The circuit is given. So this circuit is used to find the what? Resistance change. How much the resistance? Resistance change. So you can find out using the Wheatstone bridge. So based on that, how much the voltage change you can. So the resistance change you are measuring using the Wheatstone, and then after that, how much the voltage change will occur automatically because of resistance change. See, the change of resistance can be calculated, and then after that the strain will be calculated delta R by GF into R. Delta R is the resistance change, and then R is the resistance constant, then GF is the gauge factor. So if you are using this formula, delta R equal to GF into strain into R, then strain, if you want to calculate GF and R, you are bringing here. So strain will come as delta R divided by gauge factor into R. If you are using this formula, you can find out how much the strain.
Gauge factor is a constant, no?
Yes. So there are different type of strain gauges. One is bonded type strain gauge and another one is unbonded type strain gauge. When you are going to use a copper coil, so you can use small copper wires, and then you are going to put like a foil inside there, so that will be the strain gauge. So the strain gauge will be look like this. See that this is the copper coil, a small copper coil, and then the bottom one foil you are going to place. So this will be the strain gauge will look like this. Okay, so this is called bonded type. Some wire, so you can place one plate you can place, and then after that in all four corners you place one pin, and then after that when you are going to tie using one copper wire means when you are going to apply some amount of the mechanical strain on this copper wire, and you are giving some amount of the electricity means the output of electricity will be changed because of this mechanical strain. So these type of strain gauges are called unbonded type of strain gauge. Understand? Unbonded. The bonded means, so there will be a plastic foil, and then on that you are going to place some copper wire, and then after that again another one foil, it is closing. Then this type of foil you are going to paste on some steel plates. Then you are going to place means when you are going to apply some amount of force on this, then you can find out. So you can use this strain gauge to find the deflection. See the deflection of the bridge. If you want to find, so you can place different strain gauges in different places, and then after that when some load applying on the bridge, then automatically what will happen? So this will deflect, this bridge will deflect. So how much the deflection, if you want to find out, you can use this strain gauges. How much the variation in this, then you can equate with the deflection, so you can find the deflection of one beam or bridge, simply supported beam, all those things you can find out how much the deflection using these strain gauges. The same manner, if you want to find how much the load in wave bridge, so if you want to measure one lorry weight, so in the wave bridge, under that there will be a load cell. In the load cell, we are using strain gauges. When you are going to park your lorry with some with some load, then how much amount of the load you can find out using these strain gauges. Okay, using the strain gauges, you can find any amount of the load, because you are restricting. Some mechanical linkages will be there, that is restricting, and then small amount of the load will be there. Load will be applied on the strain gauge, and then strain gauge will give some output. Then after that, small output change means you are telling then 1000 ton or 2 ton or 5 ton or 500 ton, all those things you can measure by using load cell. Okay, in load cell we are using this small strain gauges as transducer. You can find force, you can find pressure, you can find load using these strain gauges. So strain gauge applications are wide. Okay, so then we will see about this thermocouple.